How's everybody doing out there? Just gonna wait to see if anybody logs on here. I finally got my machine running after a long time. I don't see anybody on here yet. Anybody on here? Hello? Okay, hey Timothy, how you doing, man? David, how you doing? Just kind of waiting for people to join in here. I finally got my machine running today. I'll show you. I cracked my bracket, so I put these on. Works great. I did just a couple test carves, making some coasters. Here's one I haven't painted yet. And here's another one I have to finish sanding, but just been playing around with it. Hopefully some more people will come on here. Oh, you're at work, huh, Timothy? It's pretty cool if you can watch us at work, man. Today I was thinking about talking about metric system. A lot of people kind of seem to have problems with metric system. And as I've told everybody before, inches and CNC do not play well together. Inches are divided up into 12, and everything in the CNC world is in 10 decimal. So it kind of makes it difficult to work with unless you have a machinist's ruler in inches that's divided up into decimal. That's the only way you can measure it and stuff. But just waiting to see how many more. How many more are gonna show up here? Hey Brian, how you doing, man? Glad you could make it. So, just give them a few more minutes here. Let people get logged in. Maybe they're finished their dinners. I don't know. But yeah, there's the thing about metric system, boy. It's a lot easier. A heck of a lot easier. And the cool thing about it, it's not just linear, but in all measurements. But I'm going to get more into it when everybody gets here. So far, we got 4 people, and hopefully there'll be more. There you go. Hey Donald, how you doing, buddy? Glad you could make it. We're just chilling out here, Donald. Just waiting for some more to log in. And tonight I was thinking we'd start off talking about metric system. And really how easy it is to work with. I just give them a couple more minutes and then I'll start. Just got to get some stuff ready here. Get something to write on. I got my machine going again there, Donald. Been playing around, making some coasters. So, man, I'll tell you what a difference with that big spindle motor. Man, oh man. It's like night and day. Okay. All right. Well, anyways, we can get started. And like I said, I want to cover the metric system with you guys, and really kind of explain what it's all about, what they use as measurements, and how everything's tied in together. Okay? And first of all, let me turn you around here. First of all, the thing that I'm going to talk about is, first of all, you have 1 millimeter. 1 millimeter. 1 millimeter, if anybody's wondering how much 1 millimeter is, I'll show you. Well, that is basically 1 millimeter. Now, it's not much. It's not much, and I can tell you right now, if I change it over, let me see, just move it. Just trying to get it in here. Well, now 1 millimeter is 0.405 inches, just so you know. So, I just wanted to show you, and it's actually 3/64. But the thing about learning millimeters is, do not try to convert. If you're going to try to convert millimeters or metric system to inches, you are shooting yourself in the foot. Okay? Do not try to convert it. What you want to do is learn it the way it is. Okay? Now, 1 millimeter, I showed you how small it is. I mean, it's about that wide. Okay? Now, 1 millimeter is equal, or let me put it this way. 1 millimeter millimeter. That means milli. Milli equals 1,000. Okay? Now, the reason I'm saying 1,000 is because everything is made up of 1 meter. Okay? I'm going to put 1 meter here. 1 meter. So, you have 1,000 milliliters, and it's millimeters, and it's telling you millimeters. Milli is 1,000. That means there are 1,000 millimeters in 1 meter. Now there are 10 millimeters equals 1 centimeter. Okay? Centimeter. Centimeter equals the same as in Spanish. Cien equals 100. So centimeters, it means 100. There's 100 centimeters in 1 meter. Okay? So you have 10 millimeters to 1 centimeter. And there are 100 centimeters in a meter. 1 meter. Okay? Now, it's so simple. You don't have any fractions. You don't have any of that garbage there at all. You don't have any quarters, 3/16ths, or anything like that. It's all on a base of 10. Now, they have one more, which is basically never talked about, but you have one called, you have 10 centimeters equals 1 decimeter. Deci means, the D means 10. So in other words, you have 10 decimeters in one meter. Okay? But this one here is basically never used. I'm just showing you. Here you have 1 millimeter, and there's 1,000 of them in 1 meter. Centimeter, you have 10 millimeters in 1 centimeter. And 1 centimeter, you have 100 centimeters in 1 meter. Okay? And like I said, decimeters, we're not really going to go through that because that's never used. So, a meter, you can break it down, equals 1,000 millimeters. It's equal, 1 meter is equal to 100 centimeters. And I can show you how big a centimeter is. That's all it is 10 millimeters. Oh, that's close enough. That's a centimeter. Now there's actually 2.45 centimeters in 1 inch. Okay? So if I bring this out to 200, let me see, 245. 245, that's basically going to be 1 inch. Wait, let me see. Just to show you here. 1 inch. So, it's basically 24.5 millimeter or centimeters. 2.45 centimeters to a meter. Or I mean to an inch, I'm sorry. But like I said, don't try to convert it. And it's so simple that once you learn the distance of 1 millimeter, and then, I mean, 10 millimeters is 1 centimeter. And 1 centimeter is basically this big. So you have 10 millimeters and 1 centimeter. Okay? Now, the cool thing the cool thing about the metric system is that it's not just linear measurements, okay? But I'm going to show you 1 liter of water equals 1 kilo. I mean, how much simpler is that, you know? If you say 1 gallon of water equals, I bet nobody knows exactly how much it weighs, but that's how crazy the American system is. Okay, now get this. In the metric system, water freezes. Freezes at 0 degrees centigrade. Okay? And then water boils at 100 degrees centigrade. Now, how much simpler is that? You know, whoever came up with 32 for freezing and 212 for boiling and 32 is for freezing. I mean, how freaking crazy is that? It is ridiculous. It's ridiculous. And I'm going to tell you how ridiculous the American system is. When you're talking about 1 yard, okay? 1 yard. 1 yard is a yardstick, okay? That's 1 yard. Now, the way they came up with 1 yard was some king or somebody in England or something like that had measured the distance from his nose to his thumb with a stretched out arm 900 years ago. Okay? Thanks, Andy. I bet you had to Google it, didn't you? Anyways, the metric system is so much easier. Like I said, water freezes at 0, it boils at 100. A millimeter is that big. You have 10 millimeters in 1 centimeter. And you have 100 centimeters in 1 meter. I mean, that is simple. Simple. Now, I'm going to show you guys a little bit about calipers. If you bought a pretty cool set of calipers, there's quite a bit you can do with them that a lot of people don't know. All right? Now, for measuring outside diameter, this is where you use the jaws. Okay. Now, the first thing you always want to do whenever you turn your calipers on is you want to zero them. You bring it in, and if it's not 0, make sure you always wipe your finger down the blades to clean them off. Clean any dust off, because it will make a difference. All right, now, okay, and mine doesn't want to, so, there. Now it's on 0. All right, now, to measure outside diameters, I want to measure the outside diameter of this lighter. That's 10.79 millimeters. Or 1 centimeter, 1.79 centimeters. Okay? Very simple, very simple. Now, that was measuring outside diameters. All right, let's just say now, on that lighter, I want to measure the diameter of that hole right there. Then you use the backside. These here are what they call inside diameters. Okay? And that's all you do is you put that down in there and you open it up. Open it up there. And that is 4.75 millimeters. So these here are for outside. These here are for inside measuring. Now I'm going to show you another thing. This part here, a lot of people don't even know this. But this part here is for measuring depth. For example, I want to measure the depth between the top here and this bottom rail here. Very simple. I put my calipers over it like that. I just hold here, and that's all I do is push it down. There. As long as you're holding it perpendicular and you hold it down, right there you see it's basically 13 millimeters deep, 12.95. And that's how you get your measurement. Just do it again, hold it, pull it down. Let me see, wait a minute. There you go, 12.6. There could be, I see I got garbage down in there. All garbage will affect, it will affect your readings. Okay, now there's some other things that you can do that's pretty cool too. For example, if I wanted to check, let's see, if I wanted to measure the distance down here, okay, and I got that 12.6 again. Now, what I can do is by using this nut, I can lock it. I can lock it in place. There. Now it won't move. Okay? And then I can zero it out. So, you can measure now. I can go and I can use this to put something in if I want to measure a drill bit. This ain't moving anymore. I can put drill bits in here and I can find the one that fits exactly. That'd be a 12 and a half millimeter. But one of the cool things I was going to show you is, for example, right now, let's say, one second here. All right. Now, I want to see how far my machine travels. So I bring this down, right down to it, and I got it pretty straight there. Okay. Now I am 3.93 millimeters from the... That's I'm sorry. My bad. I got to zero it out because I zeroed it out before. Okay, I'll do it again. I put the edge of my calipers up there and I touch right here. Okay, and that gives me 16 and a half millimeters. Now, here is where I can zero that out. Now, what I'm going to do now is I'm going to jog my machine down. And you know these intervals, 10 millimeters, 1 millimeter, 1/10 of a millimeter, and 1/100th of a millimeter. Okay? So, I'm going to put 10 millimeters here, and I'm going to jog down one time. Okay, now, since I zeroed out my first measurement, now I can just put it back up here again and measure again, and that should be pretty darn close 9.99. That's 1 millimeter. I mean 10 millimeters. Okay? So this is how you can make. Now if I take this here, there, and I zero it out again. Zero it out. Boom. Then if I go up 10 millimeters, and then I can measure it again. And there it says minus 10.35 millimeters. I mean, it depends how accurate you are and exactly where you're measuring it. But it should be basically 10 millimeters minus, because I had zeroed it out and it went up now. Okay? So, that's basically how to use calipers. Calipers, you use the wheel here to slide it. This screw to lock it if you need to lock it. Here's your inches, millimeters, and this one even has fractions. And then your on-off button, obviously. That's basically how it is with calipers. If anybody was interested, I could always go into the other calipers, what they call dial indicators. And let me just see if I have any here. No, I don't have any here. So, but then, now we've talked about millimeters, centimeters, meters, and then just like, when I was talking about meters, and 1 meter is basically 1 yard. It's almost a yard, okay? Now, why would they call it kilometers? Kilometers. Kilo means 1,000 grams. Kilometer means 1,000 meters in 1 kilometer. Kilo means 1,000. So you have 1,000, basically 1,000 yards in a kilometer. Everything is on base of 10. And like I said, you don't have to screw around with 13/64ths or none of that crap. None of that crap. It's all, if you have 10 fingers, you really have it made. Now, we can talk a little bit about machines. Upgrades. Now, I've upgraded my machine here, and I put a big spindle on it. It looks like crap right now because I've been using it, and I had tape on it for another reason before, and I just haven't gotten around to taking it off. And I actually cracked the lips where the screws come together, so I just mounted these two straps, and they really hold it well. I mean, there is no vibration. Here, I have my spindle RPMs, and it is quiet. I mean, I could sit here and talk, and I mean, if I go all the way up, and what you're hearing now is stuff that's vibrating on the table. And that's wide open. That's 12,000 RPMs. And the cool thing is I can adjust my my RPMs here the whole time. Now, what I was doing now was I was using that little trick of, let me just highlight this. Wait a second. Move it over here. Okay, now, this is what I've showed you people before. If you want your 0 point, which is right here, if you want your 0 point right in the middle of your workpiece, because what I did was by having round piece of wood. And what I did after I put my first piece on, I just made a drawing. So I can line this up right on those lines. And I can put my clamp up. One there. And I can put one here. And then I can put one up here. Just 1 second here. Put one there. And my other last one right there. There. Now I got 4 clamps. Now you see my 0 point is basically, let me see, I just got to move it over a little bit. A little bit. Wait a minute. There. There. Now I am, don't worry about that little dark mark that you see on there. That was just a pencil mark I made, but that was not correct. So now I have my part secured down, and I have my 0 point right in the center. Right in the center. So that's all I have to do now is bring it down. And I'm going to show you guys one little trick about easel. When you go to machine and you go down to advanced, okay? Advanced, here, right here. Hold up. Only modify these settings if you know what they mean. Usually on your machine, it'll probably say 3.8 or 4 or whatever. I think it's 3.6 or 3.8. That is how high, once you set your 0 point on your material, that's how high it's going to go up. Every time when it's going to go up and move over, it's going to go, I said on mine, I want it 4 millimeters. Because now, when I want to place this on my piece of wood, I can go up here to my jog. I can hit jog. I can put it on 10. I mean on 1. And watch this. I can go down 4 times. 1, 2, 3, 4. I am dead on the top of my piece of wood. Because I just took this piece off a little while ago. And it always stops at 0 point. And it'll stop at, because I have 4 millimeters on there. So now I know it's 4 millimeters above my part whenever I start the program. And that's pretty cool. If you change that number to an even number, then when you're jogging it down, it'll be equal amount of jogs. So 4 millimeters I had up there in that other window. So my machine, it was basically, if I go up 4 millimeters now, 1, 2, 3, 4, it's exactly the same as it was before. 4 millimeters. Now you can change this. You can. I would leave it at. I'm sorry. Machine, advanced. I would just put this on an even number of not 3.8 or anything like that. Now, I'm going to show you the reason I'm going to show you something here. 3.8. Okay? Now, 3.8. That means if it was if this was the end of my project and it stops right at, it comes to the 0 point and it stops there, it would be 3.8 millimeters above. And then if I have another piece just like this and I put it on, then what I have to do is I have to go down 1, 2, let me say I go down 1, 2, 3, and then I would have to go to the tenths, and I would have to go 8 times. Okay, and that would be the distance that was in here when I changed it in the machine. I'm going to change mine back because 4 is a good round number, and when you're doing several parts of the same thickness and using the same 0 point, then you just bring it down 4 clicks on 1 millimeter. Okay? We can talk a little bit about tooling. Now, believe it or not, well, that was too far up. About tooling. I'm going to tell you a little bit about tooling here. Tonight, I really didn't have much planned except for millimeters and or the metric system. Let me just get this tool out so I can show you. All right, now this is a pretty long tool. This is a very long tool, and this one here is actually a down cut. As it's turning clockwise, you can see how it's pushing the stuff down. It will be pushing all your sawdust and that. It'll push it down instead of trying to bring it up. All the other ones, they go this way when you're going clockwise. It'll be bringing the chips out of the holes. All right, now, I have seen people put a tool in their spindle and it'll be sticking out about this far. Well, let me tell you something. Believe it or not, these tools, as they are carving, they're bending. They're bending, depending on where it's cutting. It's flexing, believe it or not. You won't be able to see it, but if you measured really, really accurately, you can see that your cuts are not going to be the diameter. That it'll be a little bit bigger because these here bend as you're milling. Now, like I said, I've seen people put them in the collet like this. All right, first of all, this part right here without flukes, this is called the shank. Now, the program easel, could not care less about the shank. You could have a shank in there that big around if your machine could hold it, and easel does not care about it. Whenever easel asks you for a diameter for the tool for your what they call bit here in bit, and I only use other. I don't use any of this crap. Don't worry about any of this. As long as you're not going to pay for the pro version, forget about all this. You only need to use this right here. Excuse me. Now, when you are measuring a tool and you want to measure the diameter of it, try to get it like this. All right, let me just zero this out. Okay. One second here. There. I'm just trying to get this with one hand. All right, this is how you measure a tool. You put it in like this, and it tells you right here. This is 3.1 millimeters in diameter. Okay, and you can turn it. You can turn the tool and measure again. And here now it's 3.07. So basically you can tell that this is basically a 3.1. Now see, here's 3.15. It's all about just, you have to keep turning your tool and measuring it, and it'll give you a damn accurate reading. Now, when I was talking about the tools, okay? Here's a collet. A lot of people don't understand these either, believe it or not. If your collet is correct, then you can turn it upside down and you can shake it and nothing comes out. It's stuck in there. To get it out, to get these out, you push it down till it snap. You'll hear it kind of snap. And you see how it's cockeyed there? Then what I have to do is, just 1 second, and what I do is I grab an eraser, a pencil eraser, and I just grab a pencil eraser, okay, and once it's cocked in there, then I just take the pencil eraser in here and pop it, push it right out, and then it comes out. Okay, there's your collet. Whenever you're going to change tools, I recommend that you take your collet out. You see all these slots here? These slots, if you get one piece of dust or crap or piece of wood in there, it's not going to compress. It's not going to compress uniformly. So in other words, your tool will be off center. So you really have to keep these clean. Keep these clean. When you take your collet nut off of here, sometimes you can go up with a Q-tip. There's a cone up here, and that cone, when this goes up, this is what presses it all together. Okay? Take a Q-tip and clean out up in there once in a while. But really, I recommend that you clean these every time you change a tool. Now, to put it back in, you drop it in like this, and you push it down till it snaps. There. Now it is correct. If you are putting it in there, if you're putting it in your machine without snapping it in there, if you're putting it in like this, and you see how far back it is, and you tighten up this nut, it's going to be screwed up. Okay? It will be screwed up, and your tool will not ride 100% true. So, put it in, push it down, and you'll hear it snapped in there. Doesn't come out. Okay? Now, when you put your tool in there, make sure that the entire shank is right at the edge of your collet. You want only the flukes to be sticking out. Because the shorter you make this, the shorter you keep your tool, the less wandering it's going to do, And the less vibration, the less chatter. And with less vibration and less chatter, your tool will last longer. I've mentioned this before. People usually know this. 2 things that will kill a tool. One thing is what they call scrubbing. Scrubbing is where you're running at full RPM. You're winding it out. And your feed rate, you're barely moving, okay? So what happens there is that you're not cutting, you're just making dust. And as it cuts, it's going so fast that it's just making dust. It's cutting, but it's cutting so little at a time, it's just making dust because your RPMs are so high. After it makes its first cut, and then it goes around again, that's all you're basically doing is you have it at a real high RPM and a slow feed, and that tool is just scrubbing along the wall where it already cut. That will dull your tool in about 5 minutes. Don't scrub. These tools, they are made to be engaged. They want to be cutting wood all the time. That's what they are. They are designed to do that. Okay? And what you have to do, now, you people that have the regular spindle motor on your machine, the original, this original crappy one that doesn't have bearings or anything, and they last about a month if you're doing a lot of carving. They're not, this is a retail, this is a $4 motor, okay? And this one here, this motor here, with the potentiometer and with the power supply, and it actually comes with a big aluminum bracket that you can't use. I paid $69 for it, okay? And then I printed out my own bracket, which I do for people that want to upgrade. I print them out on the 3D printer there. Here's one that's printed out, and this one's ready to be mounted in a printer or in a machine. Now, I was talking about this RPMs, and feed rate. Now, as much as I've said it, as much as I've talked about it, for some reason, do not ask me why, but for some reason, people just don't get it. All right? What I'm talking about is when you click on carve, okay? And you get this window up. And you go through the first one, confirm material thickness, da-da-da. Clamp down the material, da-da-da. We've done that. And always read every one as you do it. This is just like an aircraft checklist. This is your checklist so you don't screw up and miss something. And that's all it does. It's telling you here. It's telling you that I have a 1.6 millimeter tool. Okay, I confirm bit size. Boom. Then it says right here, move your machine to your front left corner if that's what you're going to use as your 0 point. And then it says lower the bit to the surface of your material. Then you want to use a new position because you just set that position. So you want to use a new position. Okay? You click on this. Then it comes over here, and the first thing that happens is when you bring your tool down, I tell people, when you're bringing your tool down to touch it off, I sit like this with one hand, and I click down, down, down on the Z-axis until the paper stops, okay? First, I'll go down with 1 millimeter, and then when I start getting real close, I'll go down to 1/10, and I'll just keep clicking and clicking and clicking until that paper stops. Once that bit has stopped the paper, I leave it. Don't worry about the paper. Because in this window here, what does it say? It says raise the bit. Okay? Now, so if I raise the bit, and I went a little bit too far, so because I have such a high piece here and my spindle is down. But anyways, you raise the bit, and then it says, I have a manual spindle. So it says, confirm that your spindle is on. All right, so I turn my spindle on. All right, my spindle is on. Now, as soon as I hit carve here, my mouse, I'm going to be right up here. Right up here. Because right this here, I'm going to show you what happens. Now, I got my mouse right here. All right. Now see, I just stopped it. I stopped it so nothing would happen. This here, this disappears. As soon as you start carving, that disappears and you have the red cancel. It will cancel the program and it'll bring your 0 point back. It'll bring your spindle back to your 0 point. Now, next to it, you'll have the 2 bars, which mean pause. So let's just say, for example, you're carving away, okay? And you see up here, it's going to give you a time, how much time you have left. And then you're going to have feed override. And I don't understand why some people just don't get it. The feed override that comes up here when you start carving, it is your gas pedal and brake. This is how you adjust your machine to make it sound like a sewing machine. Okay? These machines, for you people that I haven't spoken to before or that are new here, I'm going to tell you something. As soon as that bit goes down into the wood and starts cutting, the whole machine is going to be talking to you. And it's going to be talking to you the whole time. And what it's going to be telling you is, hey, I'm just scrubbing my tool. I ain't doing crap. That's all I'm doing is making dust. So I need a faster feed rate or slow my RPMs down. Okay? You people that don't have manual adjustment on your RPMs, you're kind of screwed. The only thing you have to play with is your feed override. You can increase your feed or you can decrease it. And myself, right here on my cut settings, I have a feed rate of 150 millimeters per minute, okay? I never touch that, and I never touch this. I only adjust my depth per pass per material being used. The harder the material, the less the number on depth per pass. If I was using, for example, if I was using Purple Heart, this Purple Heart, this stuff is hard like a rock, okay? Now, if I was to carve this, I would probably have a depth per pass of probably 2, okay? And if I was using even softer wood than pine, I might go up to 0.7. But I never touch these. The plunge rate is the rate at which the tool is going down into the wood. These are not drill bits. They don't like to be pushed directly into the wood. Okay? They are not drill bits. These are milling bits. So, we slow it down to 75 millimeters per minute. These two numbers I never change because as soon as I start carving and up here I get my feed override and it will say 150 right there. And it'll have a big plus sign and it'll have a big minus sign. In other words, with the plus sign, I can increase my feed rate up to 200%. And 200% of 150 is 300 millimeters per minute. Or I can use the minus sign and I can bring it basically down to 0. So I can go from 0 to 300 millimeters per minute just by adjusting my speed there. Now, like I said, these machines are going to talk to you. Now, I mentioned one thing, scrubbing. Running a high RPM with a very slow feed, and you're just scrubbing your tool against the walls, and you are dulling it. Okay, that's scrubbing. Then you have another one called chatter. And I'm sure you people have experienced chatter. And what it does, chatter, I mean, it'll be like, and it'll be bouncing, really. And that tool is going to be chattering the whole time. Within about 30 seconds, that tool is ruined. Okay? That's how bad chattering will tear up a tool. Since we're on the thing about tools, I'm going to mention a couple more things. 90% of everybody out there, you're running these tools here. I mean, everybody has seen these, and you've seen these here. These are 3.175 is equal to 1/8 inch shank. That's the shank. Okay, and these are 22 millimeters long. All right. So those, and you have some more here. Now this one here is the same, but these are ball nose. These here are rounded at the end. These here are flat end. Right, they're flat right at the end. Okay? And then you got some more here. You see these here? These are flat end. Those are flat end. And then I have some more of these. Okay? Now, Yora Home sells these for 25 bucks. Amazon, you can get them for 10 bucks. Okay? Now, think of this. 10 bucks for 10 tools. That's $1 each. You better stock up on a bunch of them. Because with tools, you get what you pay for. In other words, these work fine. These work fine for hobby use, but don't expect them to last very long. Okay? And since I'm talking about that, there's one I want to show you here. The tool that I have in here is a milling tool. A lot of people, they say, oh, no, that's a spot drill. It's exactly like a spot drill that they use on a lathe or something. This is not a spot drill. This is a tiny end mill. Now, these tools, they come, let me see if I have one here. Uh-oh. Rut rope. Okay, I got one. Yeah. 1 second. I just lost my box there. Anyways, here is what the tool looks like. You have two ends on it. And what I do is I cut it in half so that I can get most of it. You see how much is sticking out? I have very, very little sticking out of my collet. Okay? So I try to keep instead of using this, if I put this in there, it's going to be sticking out about that far. And I don't want that. I bring it down as close as I can. So I cut it. Just take the angle grinder and I cut it off. Now, remember I told you, these tools here, $10 for 10 of them. This one here, this is a $38 tool. This tool here will probably last 100 times longer than these here. I don't recommend you get that you get these high dollar tools until you have learned your machine really good. You put this tool in here and you screw up and that tool comes over and hits your clamp, that's $38 right down the drain. Boom, gone. Okay, so I do not recommend you get high dollar tools, but it's something that you should think about later on. Different tools. Here you have, this is this is a complete ball tool, ball end, and it has flukes on it, and it will cut. It'll cut. They use a lot of these in 3D carving. Okay, here's another one. This is another $38 tool. Okay. Then, now, flukes. Here, this is a straight fluke. These straight flukes are really, really good for cutting plexiglass. If you are going to cut out a piece on plexiglass and you try to use one of these, you might as well just take your pliers and break it off, because that's what's going to happen. What happens with these here is, as they start going over the plexiglass, first of all, you have to have a low RPM, because high RPMs, like I said, and you can't really adjust it on your with easel if you don't have the potentiometer. So you're going to be running high RPM, and what happens is when this here goes into the plexiglass, it melts it, it builds up on the tool. It will build up all the way around the tool, and then it just snaps it. So, like I said, if you want to try these on plexiglass, you might as well just grab your pliers and just snap them off. So you just save your machine. They do not work cutting plexiglass. Now we also have the other tools. Where are they? The other tools. I had one laying around here. What I'm looking for is the ones that came with the printer. Oh, here's one. 1 second. 1 second here. Okay, here we go. This tool right here. This tool is really good for engraving. This is an engraving tool. This is not a end mill. This is not a milling tool. This is for fine, fine lines. Never even think of cutting any deeper than max 2 millimeters with this. And this tool here, everybody says, Oh, but that's a V bit. And we don't use, I don't have Easel Pro. And that's where all the V bits are. Well, don't worry about it. Don't worry about it. You can get around that. And the way you get around that is on your bit. For that one here, only this one, okay? This bit here. What the measurement that you are going to use for that is 0.1 millimeter. In other words, 1/10 of a millimeter. Okay? 1/10 of a millimeter it's not much. It's not much at all. But it is going to give you, let me see if I can find, I'm just trying to find some stuff that I've done on, let me see here. I usually always have examples, and I don't know what I've done with it. Let me see here. Just 1 second. No, I can't. I do not know where it is, but I have some pieces in here that I know of. Now, here is where I was telling you how if you tried to cut deep with these tools here on plexiglass, you see here, it melted on the tool and it was real big, and then it got this far and just broke. But you use this tool here on plexiglass, you get letters like this. This is like I think a half a millimeter deep, and they come out beautiful on plexiglass. I wish I had the other parts that I had to show you. I mean, here's just some of the things I've been playing with, but like I said, those tools there only for engraving, and no deeper, max depth, 2 millimeters. If I'm going to carve or engrave plexiglass, like I said, I usually don't go any deeper than half a millimeter. You don't need it. You don't need to do it. I'm just looking, because I had a really cool example of just 1 second. Now, I can't find it. I don't know where it is. But anyways, so tooling is going to be the biggest part of your job. It's about 50% of your job is tools. Selecting the correct tool. I'm sure that you people have also noticed that if you have too big of a tool on easel just tells you it will not cut it out. Now, talking about cutting out things. Here's something that most people in the group have seen it. Most of you guys haven't seen it. Some of you haven't seen it. These are inlays that I did. This here is pine, and these inlays, they're cedar. These inlays are actually 2 millimeters thick. Okay? They're 2 millimeters thick. So what I did was on the pine, I milled out the pocket for all these objects. The heart, the yin yang, the peace sign, and this scroll work. I milled out the pocket first. Now, this part here was actually all cut out in one piece. And I had it in my hand, and the pocket was right there, and I had to line it up, and it just slid right down into the pocket, just as each one of these did. And I mean, you talk about accuracy on this machine. There is no air in between these. I mean, look at that scroll work. It is 100%. Inlays are very, very cool. But again, now this one here, I used 6 days because I did not use a hogging bit to go around first and then a fine bit. What I used the smallest bit here, the 0.8 millimeters. 0.8 of a millimeter. That's what I did this whole thing with. And the reason you have to really use a small bit is because I'm going to show you a good example of. I was explaining this to a couple people the other day, and they really weren't aware of it. All right. Let's just say here, I'm just going to use this to trace. Okay, and okay, so let's just say this is a rectangle, and I'm going to do an inlay. So I want to make this a pocket. I want this to be, all this to be cut out. Now, if you're using let's say, an eighth of an inch tool. I mean, this might be a little bit exaggerated, but I'm just trying to show you. An eighth of an inch tool, you're going to have 1/16 of an inch radius. In other words, you come down here, and it's going to make a turn, and you're going to have a 1/16 of an inch radius left. You can't cut out a square corner with a tool like that. So that way, to get a sharp corner, you have to use a tiny bit. A tiny bit will cut out, it'll still leave a radius. You will never be able to get a sharp corner going from the inside. The only thing you'll get is the radius of the tool you're using. So using a 0.8 millimeter, the smallest one on there in that box, that means this corner will have a 0.4 radius. Okay? Which is not very much. It's not very much. But it still will be a radius. I mean, here you can't really see it, but there is a tiny radius there. And here. Right there's a tiny radius. Now, let's say I cut out this pocket. I can use one tool to hog it all out, and then use a tiny tool, and it will just go around the edges and clean it up. It'll make squarer corners, but it'll make them look better. All right. Then you use the exact same template, and you tell the machine the piece that you want to put in here. You tell it you want to cut outside of the shape path. So this tool is going to go down, it's going to go around, and it's going to cut it out. Now, a round tool can cut a perfectly square corner here on the outside, because that tool will just come down and it'll turn and it will cut exactly a square corner. So once you cut out that piece, you take that piece that you cut out and it would fit right down in there. First one is pocket. Pocket. The second one is cut outside. Outside shape path. So the tool will be going right on the outside. And that's where it is important that you put in the exact diameter. Because the program has to know the exact diameter so that it can offset it that much, half of it. So it'll cut exactly along the line. Okay? So that's how you get around cleaning up straight corner or sharp corners. On the inside, you have to go down to a tiny, tiny, tiny bit to get a sharp corner for inlays. Okay? Let me see, what else was I going to talk about? I talked about tooling. I've talked about tools today. I talked about what dulls them. But as I was talking about your machine, talking to you, from the time mine starts carving, the first thing I do is I go up here on my feed override that comes up here, and I start jacking my feet up. And I'm listening to my machine. And I'll turn my RPM either up or down until my machine sounds like a sewing machine. These machines are totally capable of tearing themselves apart. Okay? Do not leave them running unattended. I have seen some nasty things. Now, I can tell you one thing that really scared me was a 6550 laser machine, laser CNC, okay? And what they did was they left it unattended. And guess what happened? They came back. Something had happened in the program. The movement stopped. The laser sat there with full power, burned through the piece of wood they were using. It burned down into the table that it was on, a dining room table. The dining room table caught on fire, and the whole 6550 machine looked like a wreck. I mean, it was melted, literally melted. All the plastic on the machine was melted in one pile on the table. Okay, so these machines are dangerous. I'll show you one thing here for you people that might not know it. People that have not seen. Now, if you have a 3018 and you have your wires hanging off the back, I'm going to tell you something. It's not a question if they're going to get caught on something. The question is when they get caught on something. They will tear themselves out. Then you're going to be up a creek without a paddle. Okay? Now check this out. That's all this is here. This is a tie strip. The kind that heating and air conditioning guys use. Okay? They're the big ones, long ones. This one I think was 4 foot long. And I just cut it down. And I strapped just the tie strap to the frame, and then from here I strap my wires. Now, check how nice this moves. My wires will never, never get caught on anything. So, that is a cool way to put your wires up so you don't break them. Because in the CNC world, if something can go to shit, it will. Okay? It will. I'm not joking. It will. And like I said, these machines are totally capable of tearing themselves apart. The torque on these stepper motors, the stepper motor on the side there and on the back there and on the back all the way in the back, they are powerful. With that being said, stepper motors work with pulses, on-off pulses, and they have a pretty high amperage pulse, pretty strong pulse. Now, what happens there is that the wires that go from your board to your stepper motors, they are like antennas. They are emitting those pulses out into the air. If your USB cable, your communications cable that's plugged into your computer, if it is running parallel or next to stepper motor wires, it will screw up. And I have dealt with this for as long as I've known 3018s. And what happens is the board on these machines is an Arduino board, but not really. It is a Arduino clone. It is made in China. These machines here, all 3018s are made in the same factory in China. The only difference is you have different people that sell them. And some people gouge on prices. I'm not going to mention any names, but some people gouge on prices. You can get this machine as low as $189. Okay? But what happens with these Chinese machines? In China, they do not know the word quality control. What they found is those boards that they make, if they make 1,000 boards and they send them out untested, if they get 10 back, they don't care. They're looking at all the money they saved by not testing them. Okay? And it's really shitty, but that's the way it is. That's how China works. Now, also, these being clone boards, Chinese will do anything to save money. And they use the cheapest components there are on the market. If you had a original Arduino board on your machine, you would never have to worry about electrical noise from the wires from your stepper motors. Okay? You'll never have any problems. But these boards with the cheap components, they are susceptible to noise, electrical noise. So, what happens is if your signal cable is laying right alongside the stepper motor wires, you could have a 14-hour job, a project, and after 13 hours, all of a sudden, it shifts. It'll shift in Y, or it'll jump like in X, and just keep printing. So the whole picture is just, what happens is the signal going from your computer to the board got garbled by electrical noise from your stepper motors. And it'll screw it up. And you can't go back and fix it. That one is down the drain. Okay? So, always keep your signal cable as far away from your stepper motor wires as possible. And make sure that it has a suppressor on it. This is a noise suppressor. You can actually buy these from Banggood. You can buy a pack of, I think, 10. These are noise suppressors. Now, one more thing. It doesn't matter what machine you have, a 3018, a 6550, a Shapeco, a long mill, whatever you have. If you do not turn off your screensaver or your go to sleep mode, okay? And you're 13 hours, or let's just say if it's programmed to go to sleep after 2 hours and you're in the middle of a carve, guess what? Your machine goes to sleep, everything goes to crap. It stops. It stops and you can't recover it. Okay? Turn off your screensaver on the laptop or computer you're using with a CNC machine. Another thing, never have two CNC programs running at once. In other words, don't have easel up and running and in the background have laser GRBL running or something like that. You're asking for trouble. Okay? All right. So basically we've covered just about everything that I wanted to cover with. It was the metric system. And what I suggest you do, go on to Google. Go to Google and just type in description and overview of metric system. I really do. I highly recommend it. And I highly recommend that you get a tape measure that's only metric. Okay? Because that way you're not going to be trying to look over at the inches. Learn metric by using metric. Don't try to keep converting because you'll lose it. You'll lose it. It doesn't work. You have to learn it the way it is. And another thing, that's probably maybe next week or Monday next week or whatever. One thing I'm going to also touch on is searching. For some reason, people have a lot of problems searching for what they need. It's all about the wording. It's about the how you word your things. For example, if you're going to look for a new spindle motor for a 3018, go to Amazon. Go to Amazon and type in spindle motor for 3018 CNC 3018 Pro. And if you don't get what you want, then you just type in 3018 Pro spindle motor. Turn it around. Sometimes you'll see just by turning it around, you'll get a whole different search. It's all about the wording. And the more specific you are, the more you can narrow it down to what you're looking for. I mean, I could go in there and find objects. I can find black and white pictures of whatever I want. Whatever I want. Whether, even if it was triple X rated, I can find it on there. Just by searching. If I want a vectorized object, I'll search for it. It's all about the search. And you'd be surprised once you really get the hang of using the correct terminology, searching, you can find anything out there. Okay? So now I've been rattling my mouth for an hour and a half and hope he's got something out of it. And I really hope that all of you use metrics or the metric system on your CNC, because like I said, CNC and inches do not play well together. They really don't. Let me just show you one thing here, real quick. A good example of it. Let me see. I'm just going to move this object here a little bit. Wait a minute. Okay, I'm going to move it up here. There. Okay, and I'm just going to move it over. All right, now look at here. Now I'm in millimeters, okay? I can see that it's 10, 20, 30, 40, 50, 58 millimeters, basically. 58 millimeters by 58 millimeters up here, okay? Now watch this. Go to inches. I mean, that is about as useless as tits on a bull. That is useless. Useless. And it's just as useless as the rest of the inch system. So use millimeters. You'll get a lot more accuracy. And once you learn it, it is the simplest thing you'll ever use. You'll never have to screw with 1/64 or 1/16 or an eighth or a quarter. That will be all out the window. You have no use for it in the metric system. Metric system, a 10 is a 10 and 100 is 100. Okay? It's really, really simple. It's just, you just have to take the time and sit down and learn it. That's all. That's all. And it's not rocket science. It really isn't. Like I said, if you have 10 fingers, you got it covered. You don't even have to take your shoes off. So that was all about that, about metric system and tooling. And now I think I'm going to have to, on one of my next ones, I'm going to have to do laser engraving. Now I have a laser unit for my machine here, and I can do laser with it. On the 6550, that is strictly laser, and they use laser GRBL software. Very cool software. Talking a little bit about software, how many of you people really know what CAD/CAM stands for? CAD is computer aided drawing, which is this part of the program right here. This is your CAD part of the program. Computer aided drawing. This is computer aided machining. Okay? And here I can simulate everything. And this here is just like a cassette player. I mean, some people don't know this either, but I'll show you. This is a cassette player. This is play. And then these two here, this one and this one, You see it says ×1. So if this job says it's going to take 6 hours and 47 minutes, which is off the wall, but anyways, if it says it takes 6 hours and 47 minutes and you hit play at one time, that means it's the normal speed that you're going to be running. It will take 6 hours and 47 minutes. But who in the heck wants to sit around and watch that? So using these, you can increase ×2, ×4, ×8, ×16 times. These two here. This is fast forward all the way to the front, to the end of the program. This is rewinding it back to the program, the beginning of the program. And then I just hit start, play. Boom. You can see it's doing everything that it's supposed to do now. And it's doing it at 16 times the regular speed. Okay, and it'll show you every one. And now I'm only using one tool, so it's only going to be red. If I'm using two tools, it'll be red, and then the finishing tool will be in green. Okay? And here you can pause it, and you can say, I want to go fast, even faster. 32 times. That's as fast as it'll go. Now I continued. And you see it's working. Now it's going faster. But that's how you really get to see what is going to happen with your carving. And another thing, and I tell people this, the this here, your 3D representation here, it is an exact representation of what you are gonna get. Okay? If that representation, your preview, if it looks like crap, your piece of wood is gonna look like crap. Okay? That gives you a 100% reality check. It really does. If it looks like crap, your piece of wood is going to look exactly like crap too. If that one there looks good, then your piece of wood's going to look good. Now that there was one that I just carved out before I was talking to you guys, and this is what it come out like. I just have to clean it up now with some sandpaper, but that's what it came out like. So that preview is a 100% representation of what you're going to get. Okay? Now, you guys got enough to think about? These machines are a lot of fun. They're a lot of fun, and I can just say one thing. When you get a machine like this, and I see it time and time and time again, people will get a machine like a 3018 or they'll get a 6550, and the first thing they do is put a freaking expensive, they'll get something like this here. They'll get something like this and put it on their machine, and they're going to make a present for somebody. And they don't know their machine yet. They have not learned to use the machine. When you first get your machine, you have to be aware of one thing. You will get a lot of firewood. Okay? If you don't screw up, then you don't learn. That's what you learn from. You learn from screw-ups, okay? Everybody does them. Everybody does screw-ups. But that's what you learn from. And that's no joke. If you get one of these machines, and I tell people when they get a machine and they want to, they're all of a sudden they say, well, how do I do 3D carving? For Christ's sakes, learn how to crawl before you can walk. Forget 3D. I tell them when you get a machine, that's all you do is use these. Wait a minute, let me turn you around. Just use these icons. Use these icons. You know, take that one or whatever, or a butterfly, carve it out. Take one piece of wood, put it on there, and carve several things all over. Learn to use your 0 point. Learn to use your 0 point because a lot of people do not understand the 0 point. And I'm going to give it to you real quick right now. Just a quick demonstration of a 0 point, okay? When you make a drawing in easel, this window right here is the only thing that is going to determine your 0 point. Your 0 point is always right here. Right here. Okay? Nowhere else. That's 0 point. So, just to give you a visual representation, the distance from here to here, from that corner to that bottom corner there, you can say that it's about 12 millimeters up and about 15 millimeters to the right of that 0 point. This representation right there is never gonna change. If you have your piece of wood on there and you put your 0 point here, it's gonna start carving over here. That representation there is always gonna be there. This is where you actually set it up. So if you have that distance and you put it on the corner of your piece of wood, it's going to carve it over here. Okay? Now, if I move this down and I align my handles up on those lines, like that, my 0 point is right at the bottom left-hand corner of my object. Okay? So if I put my 0 point here, my object is going to be right here. It's going to be the lower left-hand corner of my object. Now, I was doing these here coasters. And I wanted my 0 point in the middle. I wanted it exactly in the middle. It's easy. These are handles, okay? That square there is a handle. This is a handle. And this is a handle. These here you use to scale completely up and down uniformly. This, you drag it out to stretch it horizontally. This one you drag to stretch vertically. But I also use these as aligning tools. Now watch this. I grab this and I move it down here and I align my handles exactly right there. You see my middle handle there is exactly in the center there, and this handle here is exactly on that line. Guess what? My 0 point is now right here. This representation here will only show you if you use your 0 point here. You see it right here. It's telling you this is your 0 point. There's no way to change it here. This is just a representation. Now, on my workpiece, that's all I had to do was I know where my center is, and that's all I do is bring my tool. I bring my tool to the center, and I touch it down, and that's my 0 point. Okay? There's my 0 point in the middle of everything, right there. There's my 0 point right in the middle. Okay? I take it out. There's my part right there. You can see actually where my tool touched down. All right? So that is how you do something if you want to center it. Use the 0 point the correct way. Now if I was to move this object way the heck up here, that distance is still going to be that distance. So, I mean, just to give you a visual, if I put my 0 point here, it's going to carve up here. Your machine has a floating 0 point. Wherever you put your tool down on the piece of wood, you are telling it, that's where I want my 0 point to be. And then, it's just like here. That's where your 0 point is 0, 0. And wherever you put that down is going to be 0, 0. But you see there, the difference of that distance here is going to be about 28, 27 millimeters above. And it's going to be about 20 millimeters to the right from your 0 point. So remember, this window here determines your 0 point. Okay? This is how you manipulate your whole 0 point to be wherever you want it. If you want your 0 point right down at the bottom left-hand corner of your object, fine, right there. Move your handles so that they're lined up there and lined up here. And then, if you want your 0 point exactly in the middle, you just move it down and you line up your handles again. You line up that. Batteries on my mouse are starting to go bad. So I line it up. Oh, I keep hitting the... Right there. I'm lined up there. And I'm lined up here. My 0 point is exactly in the middle of my piece. My object. Wherever I put my 0 point, I could put my 0 point here. And my object is going to be right around it. I could put this over here. And it's going to be right around it. I can put it over here. It's going to be right around it. This is a floating 0 point. Okay? So, I think we've pretty much touched on quite a few things here. I hope you guys got something out of it. Actually, there's quite a few people here today. So, I really thank you guys for joining me. Send me a message on Messenger if there's something specific that you want me to bring up as a topic. Okay? I'm open. If you want me to do laser GRBL and, using a laser, I'll do that. I'll also can touch on things, for example, on easel too, how to bring in pictures. There was one guy, Bob, was asking about bringing in pictures. And it can be done. It's, the way you do it is, I get rid of that. You go down here. Let me see. Turn it around. To bring in a picture, go to here. Import. Image trace. Bring in image trace. Here it says, upload an image to begin. Upload a file. select a file to upload. I'm glad my machine is really fast. So, okay. Yeah, okay, so if I wanted to try to get a picture of the airplane that I built, all right, there's the image right there, okay? So what I do is I upload it. And it's going to come up here. Now, you see here, now I have to use these sliders. And what I usually do is I'll go basically from one extreme to another, and you see what happens. Boom. That's one extreme, and that's the other extreme. So then I start bringing it up a little bit at a time. So I go back a little bit. And then this one here is smoothing. And it doesn't really do much. So there's not that much difference. So I just kind of put that in the middle. And then here's line trace. You click on that and it'll make lines. Now I can readjust it and see if I can get a little bit better picture. Oh, that's almost too much. But these are things you have to play with. It's just, and a lot of times what I do is I'll bring my picture into Inkscape first and make it into a black and white picture. And then what I'll do is I'll make give it a high contrast so that this program basically has something to work with. This picture here that I brought in basically sucked as a picture. Here's a picture. No. I had one here. I was going to show you. I'm going to show you another example. I can't find it. Or wait a minute. Wait a minute. Let's see if I can find this one. It's pretty cool, actually. But when I'm looking for it, I can't find it. So here it is. Here it is right here. All right. This here picture, I fly two-line competition kites. And I was out at the beach flying it. And a flock of birds came over. And my girlfriend got a picture of it. Well, this is it. This is a carving from that picture. So this is what line trace does. You can bring pictures in and convert them into lines. So, yes, Rob. Rob, yes, by clicking raise the bit, it's supposed to lift the router. Yes. Okay, I'm gonna quit here for tonight. Like I said, now I've run my mouth almost 2 hours, and I bet your heads are pretty full, so you have a little bit to think about. But just trying to help you guys out. If there's any questions, or if anybody wants one-on-one instructions, I do it for free. I enjoy doing it. I do it on Messenger. We make a set a date when it suits both of us. I'm retired, so I'm available from noon till 6 o'clock at night. And I mean, just make a date and I'll get a hold of you and we'll talk. We'll go through your machine. I'll teach you everything about easel, your machine, everything. You will feel confident when I'm done with you, okay? And it's free. I enjoy doing it. It keeps my brain sharp. All right, I'm going to let you guys go and have a nice week. Everybody be safe out there. This crazy shit with this COVID-19, man. Boo. Anyways, everybody be careful and take care, okay? And have a wonderful evening, and we'll see you next week. Bye.